And in the vernacular of quantum physics, when you make the measurement, that is, when you collect the information, then the wave form collapses to a particle. Then you get a little chunk of mass. But the particle fundamentally is just probability. You see, so quantum physics, and that was the very early first quarter of the 1900s, the 20th century. So it's about 100 years old now. Mm-hmm. And that was a real big bomb going off in the world of physics, because this said that materialism fundamentally was wrong. The problem was that the physicists could not come up with any other explanation. They couldn't say, well, okay, well, here's why, particles really should be probability distributions. They couldn't come up with that other theory that, explained this. So after some, I don't know, maybe 20 or 30 years of trying and coming up empty-handed, they took a different approach. They said, well, we're just meant not to know this. This is one of those secrets of nature that we'll never know, and it can't be known, and we'll just call quantum mechanics weird science. It's just not like other sciences, which are fundamentally logical. This one is not. It's got this non-intuitive, non-local thing about it that we'll just never know. So that got them off the hook from trying to figure it out, because they decided that it was impossible. And instead of coming up with solutions, they decided that it was just weird physics and would always be weird physics. So at that point, they went back to materialism with this odd, weird physics that just didn't kind of fit, but it was an outlier. It was a kind of an outside case, so they kind of said, well, that's different. So that was their thinking. And most scientists today, particularly the older group, are still, caught in the Newtonian viewpoint of reality, which is the clockwork universe, that materialism is how this universe works. Material things are fundamental. And it's a strange thing, that physicists would stick to that, because there's so many things in physics that are very basic things. Physics has just a few basic things, and everything else in physics is how these basic things affect each other and how they change and how changing one affects the other. So the basic things are like time, mass, charge, spin, space. I don't know, maybe forgetting a couple of them, but those are the ones that come to mind. And gravity, that would be one, gravity. So these are the basic things. And now everything else is kind of made up of these. But if you ask a physicist where any of these basic things come from, what is their causality? What causes time? What causes mass? What causes space? What causes charge? Where does that come from? They'll say, I don't know. It just is. Okay, so that is a real, lack of logic there in their beginning, just to say it just is, because we see it, and that's why it's there. So the very basic things of our world are things that are somewhat mystical, because they have no physical causality. They just are. Well, things with no physical causality is what we call paranormal. If you don't have any physical causality, then it's not normal, it's paranormal. So at the very heart and root of physics, all of their basic assumptions are paranormal. You see, they're mystical. These things just come out of nowhere. So that tells you that the theory has problems. When you get that kind of like quantum mechanics is just weird science, well, that tells you the science is incomplete. So it's just obviously incorrect, because quantum physics is a logical science. And the fact that this is a paradox, you see, and quantum mechanics comes with a whole basket full of paradoxes. This is, this one double slit. That's just one of them, but there's lots of other things that are...
Schrodinger's cat, for example.
Yeah, we have that. We have tunneling, things...
Superposition, all these things.
All this stuff are just... There's a lot of paradoxes that we know they're like that, and we know that the math works that way, but we don't know why they should be that way. Well, my thing, where I started was that I had two careers. All the time, from shortly after I took my first job out of graduate school, I met Bob Monroe and started working also studying consciousness. So my career in physics and my career in consciousness both started about the same time. And my career in physics was a full-time job. My career in consciousness research was pretty close to a half-time job, anywhere between 15 and 20 hours a week. I was put into that out at the lab with Bob Monroe. So I eventually had a set of facts in consciousness from my own experience, with consciousness and with the out-of-body and the remote viewing and all these things which are artifacts of consciousness. So I had facts, things like I just mentioned that the consciousness is fundamental and the physical world isn't, just because of how causality flows between the two. So I had these facts, and I had a bunch of facts of physics because I was a physicist, a bunch about the physical reality. And I wanted an overall understanding that was simple and elegant, with no unusual assumptions, that answered all of the facts. My basket full of facts in consciousness, my basket full of facts in the physical world. So 35 years later of doing this research in consciousness, coming up with those facts, because they're a little harder to get than physical facts. You have to work at that a little bit. You have to repeat experiments over and over and over again and isolate variables and do all that sort of thing. So it took a long time to do these consciousness facts. It had to be repeatable. You had to know why things were the way they were and how they varied with other parameters. And so it took a long time. So it was about 35 years later, I thought I understood consciousness well enough that I could come up with a theory that explained both consciousness and would derive physics. And it does. It derives quantum mechanics, from the very beginning, and it gets the right answers. And not only that, it solves all of those paradoxes. All those paradoxes then have a nice logical solution of why they are the way they are and why it really couldn't be any other way. So then I started looking for other paradoxes, paradoxes in psychology and paradoxes in neuroscience and other kinds of paradoxes in biology, and found that all these paradoxes resolve themselves from this viewpoint of our reality is a computed reality, a virtual reality, our physical reality is, and consciousness is the source. Consciousness is a part of the consciousness system, which is an information system, configures itself as the server that serves up the virtual reality. And another part of it is you and I, individuated units of consciousness. So this source plays all the roles. And then I started developing the logic of meeting all those things I learned in studying consciousness and in the out-of-body experiences and the remote viewing and those sorts of things. So that's where the model comes from. It's basically just trying to come up with something that fit everything, explained all the data that we have, and explains new stuff. It explains a whole lot of things that we don't know now, like where does space and time come from? Well, this theory has a causal reason for those things. They don't just magically appear because they appear.
A lot of physicists have been trying as well to come up with answers because of all these paradoxes and loose ends that they are trying to tie up and fit into a bigger picture. One of the, to me, more interesting concepts, apart from just saying it just is, which is a very unscientific way of going about things, just accepting things for what they are and stopping to look. The more interesting things that I found the idea, the concept of the implicate order by Prima Bohm. You may be familiar with them. You know, they are around the time that Einstein, you know, released his general relativity theory, or was already established, and they were in his wake or even on his team for some time. But apparently, in some aspects of the theory, they deviated, and especially David Bohm reasoned that from what we see and from what our experiments tell us, the information that we get from that is there is some pattern, some larger information at play here, which he called the implicate order, that seems to inform all these processes and we get to measure and look at and record and whatnot. Would you like to comment on that?
Well, Baum, you're right. He does say there's this thing behind the curtain, you know, that is, as a metaphor, you know, there is this thing behind the curtain that is important, that's fundamental, that's more fundamental than what's out here in front of the curtain. And I would agree with that assumption, and that's what my larger conscious system is. It's that thing behind the curtain. That's what consciousness is. Not just the larger conscious system, but consciousness is that thing behind the curtain. So talking about the Big Bang and the fact that there is no logical reason why that ball of plasma, you know, was sitting there under a very high temperature and high pressure, and then suddenly, bang, you know, and everything after that started to evolve and evolved according to science, you know, to the rules, you know, gravity, explosions, pressure expands, you know, gravity pulls things together, you know, as it expands, it cools, as it cools, you know, it comes into, it clumps and, you know, all of that sort of thing. Well, that's the rule set, okay? And that ball of plasma is the initial conditions. So when I say that consciousness made a virtual reality, they started with initial conditions, which was that ball of plasma, high temperatures, whatever, and a rule set that was going to define the virtual reality. And then they hit that run button and big digital bang. And the simulation started to compute, and the initial conditions began to change according to the rule set. And of course, that's a dynamic thing. So they kept changing. And the fact that we have a set of constants that if any changes were made in these constants, even in the 10th or 12th or 15th decimal place, then the universe would have collapsed. It wouldn't be here. You know, it wouldn't be a stable, viable universe. It's only here because of these things balance just perfectly. And it's not just one number, it's a whole set. It's a set of numbers that all balance just perfectly. Matter of fact, physicists have named that, I think, the anthropic principle. And they call it that because it looks like it was designed just for us. So that's why they call it anthropic principle. But it's a big mystery. It's one of those paradoxes. Well, the solution is simple. If the larger conscious system is creating a virtual reality so that consciousness will have more meaningful experiences, then it starts with this idea of I'll need initial conditions and I'll need a rule set. And that then will evolve to be this virtual reality. So the virtual reality is evolved, not programmed. And we have evolved virtual realities going on in computers in some of the better computer science departments and universities, you know, all over. They do these same things. Not as elaborate as the one we live in, but they still do it. You know, the idea works and works fine. So the virtual reality started to evolve, and I can see that this evolution is a trial and error sort of thing. So the fact that we have this anthropic principle that has this set of numbers so precisely defined so our universe remains stable enough for us to have evolved here, well, that's explained. That's logical. Well, of course we do. That's how you make a virtual reality like this. And you'd want to make a virtual reality that was evolved, not programmed, because the programming would be just outrageous, too much, and it would be fixed. You know, you'd make it up as you went, and it wouldn't be consistent. Whereas if it evolves, it's all perfectly consistent with the rule set. Everything works together perfectly because it all evolved. together.
You mentioned stable systems. I always wondered, why shouldn't it have state at nothingness? Doesn't that sound like the most stable system at all?
It's stable, but it doesn't do anything or go anywhere or have any meaning or have any significance. So it
certainly doesn't evolve,
No, it's the null set. Stable, because once you have nothing but a null set, then that's what you have forevermore. It's just a null set. So there's no value in it. It doesn't go anywhere. So as a concept, yes,